The functions f, g, and h satisfy the relationship f of x is less than or equal to g of x is less than or equal to h of x. In other words, g of x is sandwiched in between f of x and h of x. So that happens to be on the interval 0, 3. I'm not sure if that's going to be any important here, but it is also known that the limit as x approaches 1 of f of x, which is u, is going to be 4. And the limit as x approaches 1 of h of x, which is u, is also going to be 4. So this guy is called the squeeze theorem. And basically what it says is if you have a number here that's equal to the number here, then this guy's got to be equal to both of those numbers. You're 4, which means it only makes sense that 4 is going to be quote-unquote in between them. So when it asks us which of the following could the limit as x approaches regular 1 of g of x be, well, there's only one option, and that guy is 4. So again, that uses the squeeze theorem, and it basically gives you the idea that if you have something in between two outer functions like these guys, and these outer functions are the same, the guy in the middle's got to be the same too. So yeah, squeeze theorem, it's fun. Let u and v be functions defined as u of x is negative e to the x minus 2 minus 3, and v of x is a half x squared minus 3x. So there's u, there's v. Given f is a function that f is in between u and v, what is the limit as 2 approaches f of x? Now this guy uses the squeeze theorem. And basically what the squeeze theorem says is if you have the limits of these two outer guys right here, then this guy's got to be in between the limit of that and the limit of that if given a specific limit. Well, we are given a limit as x approaches 2. So this is what I want to do. I want to find the limit as x approaches 2 of u of x. And when I do that, this is algebraic. You plug in 2, so that'll be e to the 2 minus 2 minus 3. Actually, negative e. That will actually make a difference. You'll see. But that's going to be negative e to the 0th minus 3. Negative anything to the 0 is going to be negative 1. And negative 1 minus 3 is negative 4. So that's the limit as x approaches 2 of u of x. If I do the same thing, the limit as x approaches 2 of v of x, we're hoping that we get negative 4 as well. So let's see what happens. 1 half x squared is going to be 2 squared minus 3 times 2. 1 half of 4, because 2 squared is 4, minus 6 is going to be 2 minus 6, which is negative 4. So, since the limit of 2 of u of x was negative 4, and the limit of 2 of v of x was also negative 4, then the limit as x approaches 2 of f of x is also going to be negative 4. So that's the squeeze theorem. Squeeze theorem is very bizarre, not the most useful thing on the planet, but that's what you do on a problem like this. Evaluate the limit as x approaches 0 of x squared of sine 1 over x. So what we're going to do with this, guy, is we're going to use what's called the squeeze theorem. Now there's a little rule that says that if you were to take sine of 1 over x, you can bound them in between, or bound that in between negative 1 and positive 1. Now this is what the squeeze theorem looks like. The squeeze theorem says, look, if you have three things, one on the outside, one on the outside, and one in the middle, and if you take the limit of all three of them, and the outside guys are the same thing, then the middle guys are the same thing. Now this is not this. So if I were to multiply this entire inequality by x squared, that would give me negative x squared is less than or equal to x squared sine 1 over x, which is also less than or equal to x squared. Now what I'm going to do is I'm going to highlight this one in green, and I'm going to take the limit as x approaches 0 of that guy, of negative x squared. If I take the limit as x approaches 0 of negative x squared, that gets me negative 0 squared, which just ends up being 0. So u becomes 0. If I were to take this guy and do the same thing, and take the limit as x approaches 0 of x squared, I plug in 0, and 0 squared is 0, which means this guy right here is 0. And so, if 0 is less than or equal to the limit as x approaches 0 of x squared sine 1 over x, which is also less than or equal to 0, since I took the limit of u and got nothing, and I took the limit of u and got nothing, that means taking the limit of u is going to give me a big fat 0. So the answer to this guy is 0 by using the squeeze theorem. Kind of tricky, but lots of fun.